So let's consider the library using R, and then the father.son data. And I'm just to make my life a little bit easier, I'm going to define X here as the son's height, just so I don't have to keep referring to the data frame. Let's let N be the number of observations, and then I'm going to do 10,000 bootstrap resamples. So what I'm going to do now is the sample command. So when I say sample X, that means draw from X N times B numbers of resamples, where in every case because I put replace equals true, every time I take an observation, I take a son's height out of the bag, I put it back in. Okay? And so what is this? This is simulating from an empirical distribution defined by our data that puts probability 1 over n on each observed data point. This is called the empirical distribution. And then I'm going to arrange these in a matrix with number of bootstrap rows and number of sample sizes columns. And so what that means is every row of this matrix that I'm calling resamples is now a completely resampled data set where I took my original data and I drew a sample of size n with replacement from that data set. And that's exactly equivalent to regenerating a sample of size n from a distribution that places probability 1 over n on each observed data point. And then let's suppose that the statistic I'm interested in is the median. And so I'm going to take for each of these data sets, each of these resampled data sets, and I'm going to apply the median. And that's what this final apply statement does. So here's a density estimate from the resampled medians. I've drawn a vertical line for our observed median. So what we've done in this case is we've taken our vector of son's heights and we've repeatedly drawn from this collection of son's heights a new data set of the same length where we drew with replacement with equal probability on every observed data point. Then for each one of these new data sets, we calculated the median. We did that 10,000 times, and we got a collection of medians. What this density estimate is an estimate of the distribution of medians where we don't know the actual population distribution, we're estimating it from our observed data. This is the central quantity used in bootstrapping. For example, in this case, we're bootstrapping the median, and we might want to do something like take the standard deviation of this distribution, and that is going to be an estimate of the standard error of the median, right? The standard deviation of the sampling distribution of the median. We could do, for example, quantiles to get confidence interval estimates, and these are the sorts of things that you do with your bootstrap resample distribution. So let's go through a couple of the principles and just rediscuss bootstrapping generally, and then we'll work through this example a little bit more.